Question 18 describes the flight path of an airplane as a linear equation and the airspace borders as a quadratic equation. And it asks you to find the points where the flight path of the plane will cross the borders of the flight space. In other words, find the points of intersection. You've got a linear equation, so the path of your airplane, and a quadratic equation, which is the flight area. We rearranged the linear equation. You could also have rearranged this as y equals -3 minus x, and then you would simply sub in the -3 minus x anywhere that you see y in the quadratic. However, just because I've arranged it as x equals, and I will be subbing this in for the x term in the quadratic. So do that. Very carefully square out your bracket. Remember, square the first, square the last, twice the product. Then the remaining equation stays the same. Everything over to the left and tidy it up. I can simplify and factorize. I have y equals 1 and y equals -4. Then if I sub these in, so when y equals 1, sub in the values, and I get x equals -4. When y is equal to -4, sub it into the equation for x, and I get x equals 1. So the 2 points where the flight path of the plane intersects with the borders of the flight area are -4, 1, and 1, -4. The question then goes on to describe how the control tower is at 0, 0, and it wants you to describe these points of intersection, in terms of east-west and north-south kilometers. So the handiest thing to do for those is to just sketch them on your axis, plotting them really roughly, but marking in north, south, east and west. So as you can see, your first point, -4, 1, is 4 kilometers west, because it's 4 kilometers out here, and 1 kilometer north, because it's going up in the north direction. Obviously, we don't describe it as -4 kilometers because you don't have negative distance. Then the other point, which was 1 -4, is 1 kilometer east and 4 kilometers to the south. The last part that they ask is for you to calculate the distance. Okay, now the coordinates are the same, so the distance will be the same. So you just calculate it once, and it's based on the idea of Pythagoras' theorem. If you're to draw a line from the center out to the point, or from the center out to the point, then a line down touching the axis, you form a right angle triangle. This sounds familiar because you would be quite used to seeing it in your trigonometry and your coordinate geometry from junior cert. So we take our distance formula, or better than that, you could describe it in terms of Pythagoras' theorem, like I was saying. So you've got the squared length of the hypotenuse is equal to the sum of the squares of the other two sides. So if we call the hypotenuse, i.e. the distance we're looking for, we call that x, so x squared is equal to 4 squared plus 1 squared. And again, even if you choose this point, there's your hypotenuse, 4 squared, 1 squared. So it doesn't matter. You end up with 16 plus 1, so x squared equals 17. X is equal to the square root of 17. Now normally we would have plus or minus, but again, this is distance, so the minus is going to be invalid, so we just ignore it. And x is equal to 4.12 kilometers. Now I rounded to 4.12 because it says in the question to give it to 3 significant figures, not 2 decimal places. Be aware of that. So significant figures, 1, 2, 3 significant figures.